Hello, ninth grade extended students. Today we are going to learn about concurrence theorems. The first point of concurrency is called the circumcenter. And the circumcenter is the center of a circle circumscribed about a polygon. So if I were to draw this polygon in here, the center of that circle would be the circumcenter of the polygon that I just drew. So H is the circumcenter of A, B, C, D. The next point of concurrency is called the incenter, the center of the circle inscribed in a polygon. So if you look at this isn't the circle's inscribed in that polygon, and I is the incenter. I is the incenter of A, B, C, D. Some more vocabulary for you. Concurrent lines are three or more lines that intersect in exactly one point. Here are some examples of circumcenters. So you'll notice this first one is inside the triangle, this one's outside the triangle, and this one's on the triangle. So inside, the circumcenter can be inside, and that happens when the triangle is acute. It can be outside when the triangle is obtuse. And it is on when the triangle is a right triangle. Theorem 128 says the circumcenter is equidistant from the vertices of the triangle, and that should make sense. This point, from here to here is a radius, here to here is a radius, and a radius there. So it's equidistant to the vertices. The incenter is the point of concurrency of the angle bisectors. Of a triangle. Any point on an angle bisector is equidistant from the sides. So if I look at this point right here, it's the same distance to the sides. And so now this should make sense. All those segments are radii of the circle. So therefore, the theorem 129 says the incenter is equidistant from the sides of the triangle. That distance represents the radius of the circle. The next theorem says the altitudes of a triangle are concurrent. In other words, if I draw three altitudes in a triangle, they will intersect in exactly one spot, and that spot is called the orthocenter. The centroid is the point of concurrency of the medians. of a triangle. The centroid is 2/3 away from each vertex of the triangle, as from the centroid to the side. So basically this means that it splits each median in a ratio of 2 to 1. This is 2 times x. This would be x, 2 to 1. What's special about the centroid? It is the center of gravity of your triangle. Here are some examples of centroids. Remember, a median joins the vertex to the midpoint of the opposite side. So in my acute triangle, I can see that my centroid is inside the triangle. In an obtuse triangle, the centroid is still inside. And for a right triangle, it is still inside. The centroid is always inside the triangle. Okay, take a minute to write down the summary of all the special characteristics of the circumcenter, incenter, centroid, and orthocenter. They are the points of congruency for triangles. I wrote 2 to 1 here because my medians are divided into a 2 to 1 ratio. When you're done with this, start working on the assignment that I posted for you. Have a great day.